And I'm really bad at it, I know. Bad students are like, okay, just tell me where we are. I don't know. I just know a lot of shit. I'm trying to tell you. I have no idea where it is in the book. But yeah, this is 11.3. It's like studying solutions to quadratic or whatever.
Yeah.
Some of us had some issues, and I understand if it's the first time you saw it, maybe you forgot. So some of us forgot. The biggest thing people forgot was this is b squared inside. And then some of you guys multiplied it by 4ac. And some of you guys didn't make that go all the way. I mean, there's little tiny things. So what we talked about this before, but that was before the test, so maybe we forgot. What part of this equation, let me start off with this. What part of this equation tells me there's going to be two solutions? Why would there be two? Yeah, the plus or minus. I love it. Plus or minus this. So what if b squared minus 4ac was 0? What would that mean then, considering what we just said? If that piece is 0, so I'm adding and subtracting 0, do I get two answers still?
One repeated solution.
Look at you. Stop it. Don't look in there. I want you to think about it. But you guys see, I mean, the reason there's two separate solutions
A negative and a positive.
is because plus and minus something. Well, if that's nothing, if that's 0, then I only get the one answer. I like it. It is repeated. That's why there's two of them. They just happen to both be the same. I like it. So if b squared minus 4ac equals 0, we get one real solution. It's repeated. So let's do an example. Let's see what the hell this thing would look like. Let's check it. How can I check it? If the question just says, how many answers will this have? I only have to look at one thing. b squared minus 4ac. I really want this to make sense. If the question doesn't say, what are the solutions? Don't solve the whole damn thing. If it says, how many and what type? We'll talk about the what type in a minute. If it says, how many solutions would there be? I only have to look at this guy. If he is anything except 0, there will be two answers. If he equals 0, there will just be one answer. So in this problem, what's b? -6. What's a? 1. And what's c? 9. So if I do b squared, take a minute and do this. b squared minus 4ac. Just do that piece. You know what b is, you know what a is, you know what c is. Figure out what b squared minus 4ac is. Should see it relatively quickly. I like that sound. So b is 6. 6 squared minus 4 times a times c. 36 minus 36 is 0. Now watch how this is kind of like, bless you. Bless you. How do I factor that? Just this, because that's the easiest way to solve this. How do I factor this? Yeah. So see how there are two answers? They both happen to be 3. So there still has to be two answers. They just both happen to be the same number. So it's sort of like if you made $300 and you made $300, and I say, how much do people make? You say 300. Why is there just one answer? There's two people. They both made $300. There's still two people. You guys understand? I'm trying to make sure you understand the fundamental theorem of algebra must be true. If it's squared, there has to be two answers. They just both happen to be the same amount.
So the answer is -3?
No.
Or is it 0?
No. It would be 3, right? What makes it 0?
Oh, okay.
3. Yeah. Remember, you got to think backwards when you're solving these things.
So by factoring, you can get the answer?
Yes. That's why on that sheet I gave you that lists those 4 main methods. What's the very first method listed? Factor. Because I only do the other shit if I can't factor. Factoring is the quickest unless you hate factoring, and that's bad. Because factoring's everywhere, right? Maybe. Some people that don't like factoring, they love quadratic because they're like, oh, good, I can get the answers. But you still have to factor in other places too, so you might as well learn how to do that if you're still having trouble with it. All right, how are we doing so far? You guys all right? You look tired, I understand. Okay. So, what if b squared minus 4ac is greater than 0? So, of course, what kind of number is it then? If it's greater than 0, it's a positive number. I like it. If it's positive, then you get what kind of answers? Real. And how many will you get? So if this is greater than 0, I won't just get one. I'm going to get 2 answers, and they are both real. Because what's the only way I can make a complex number if the part under the radical is? How do I make a complex number? The part under the radical has to be negative, less than 0. Right? So if it's greater than 0, you get 2 real solutions. And if it's less than 0, you get 2 complex solutions. So let's see. Let's try one of these out. So how many and what kind of solutions will this have? So how many and what kind of solutions to this? Don't nitpick my grammar. Where are we at? Let's do 4x squared. So did I ask you to solve it? No. If you solve it, you'll lose points. And you're like, what? Well, you will, because you did more than the question. You have to show me you understand what the question relates to. If I ask you how many and what kind, didn't say solve. So what do I look at? b squared minus 4ac. I love it. So investigate this. Take a minute and figure out what kind of number that is. And then you can see what situation we're in. So let's see, what we got? What's b? Negative 5. What's a? 4. What's c? Negative 6. This tripped a few people up, but what sign will this chunk have? Positive, because negative times negative. Right? So actually, you don't even have to get the number. I know this is going to be positive plus something that's greater than 0, right? But just to get the number, 25, what's all this mess? 96, I like it, so that's 121. And that is greater than 0. So how many solutions and what kind? 2 real. Why is that less of memorization and more it just makes sense? Well, plus or minus will still be alive. That's positive, so it's not complex. You don't have to memorize it, just see why it makes sense. Or memorize it. I mean, whatever you got to do. How you guys feeling so far? You guys all right? You look beat up, but that's this kind of time of year. I got my few punches in. All right. So, what about this here? Sure. I like it. is 2, B is 7, C is 4. So it'll be B squared minus 4AC so you're 49 minus 32. So again, it'll be 2. Keep going.
2 real numbers.
2 real solutions. I like it. So let me ask you something real quick. Does anybody see, is there a number I could change by just a little bit? Any of these 3 numbers that you can change to have it have complex answers? Anybody see that? Which number could I change? Why did this come out real? Because this piece is smaller than that piece. So I didn't subtract enough to make it negative. Do you guys see that? So I'm trying to push you a little bit beyond the basic shit. So if I would have made this, if I make it 5, that'll be 40, still not big enough. 6 would work, right? Well, let's see, 6 would make it, no, it's 48, still not enough. You have to make it 7. Or I can make this guy something bigger. Do you guys see what I'm saying? A little, no. So can you see in this problem what it is that made the answer come out positive? This is too big, or this is too small. So it could have just made this 3. Then it would have been 9 minus 32. That would have been negative. Okay, I know I'm pushing it a little bit more than you have to know, but it's nice to be able to just look at it and go, what part of this made this happen? What would I change to make that not happen? We will talk a little bit about what those changes would do to the graph of this thing. Not too long from now, yes.
So why is it minus 4 when there was an or what it was addition in the beginning?
What was addition?
The problem.
What are we always investigating in these kind of questions? This piece of the quadratic.
Okay.
Is that the question? Because it's
Yeah.
always minus 4.
Okay.
Why? We saw exactly why. We did all this the solution to that. 8x squared plus bx plus c. I like it. Okay. So that's not a big deal. It's sort of like going, well, this is a square root piece. That's where things could get all freaky. And this is just saying what 3 things could happen. Less than 0, 0, greater than 0. Okay, maybe. I can't read you guys. All right. Now, watch. I think I might have asked this kind of question before in a bonus, but I can't remember. Can you create a quadratic, become a word, equation with solutions 7 and negative 2? So I want 7 and negative 2 to be answers. Nowhere near as difficult as it sounds. Just got to remember, if I have a quadratic thing, blah, 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 and I factor it and I get to this level, what will the answers be? 3, negative 11. All right, now I'm starting. I gave you the answers. Can you take the next step backwards? Where would they have come from? Where would 7 have come from? X by 7. Where would negative 2 have come from? And then to make it quadratic, you just FOIL that bad boy out. X squared plus 2 minus 7, and then negative 7 times 2. So that quadratic equation would have those solutions because we built it to have those solutions. All right, let me push this a little bit more because this is kind of a big, important idea. So remind me, the only way, what's the only way I can get any complex answers out of this? If what's true? Yeah, if this guy is less than, if it equals 0, I get 1 real answer. If it's greater than 0, I get 2 real answers. If it's less than 0, that's the only time I get complex answers. So how many, if I'm going to get a complex answer, how many complex answers do I always have to get? 2. plus or minus. And what's really, really neat, at least to me, is if you get a complex answer, its conjugate is the other answer. Of course it is, plus, minus. Right? So if 3 plus I rad 7 over 5 is one answer, what's the other answer going to be? 3 minus I rad 7 over. And those are conjugates of each other. Right? So if I have one complex solution to a normal quadratic equation, I know its conjugate has to be there also. So let me see if you guys get this next question. So create quadratic equation with x equal to I plus 5 as a solution. So there's two kind of levels to this. This is such a nice, beautifully evil problem. I love it. You have to first realize, okay, if it has I plus 5 as an answer, what else must it have? I minus 5 as an answer. So that means it's got I plus 5. So this is what we're going to realize. Let me put that in a different color. We realize it has to also have I minus 5 as an answer. Now, what's really going to be disgusting is, what did I do with 7 to build up my equation? It came from x minus it. This came from x minus negative 2. That's why it's plus 2. So where did this come from? Do it.
I minus 5?
No, come on. Where did 7 come from? X minus it. Where did negative 2 come from? X minus it. So where did I plus 5 come from? X minus it. Oh, shit. Oh, shit. And where did the other one come from? Careful. X minus I minus 5. Doesn't that look like such an awesome thing to multiply? Go ahead and multiply it out. Roly raspberry. I would highly recommend you distribute it negative in both of those. So you're just going to have like 3 distributions and then another, right? So you have to distribute the x, you distribute the negative I, and then you have to distribute the I. Not harder, just more. Right? So let's see what you get. Squared. Minus ix
Minus 5x.
plus 5x. Right? And then you get, let's see, that's going the x through. And we bring the negative I through, what do we get? Negative I times negative I. This is another place. What is I times I? It is the most important one out of all that stuff. What is I squared? Negative 1. So a lot of people tripped up on that test because of that. If you see an I squared in a problem, you replace it with negative 1. So let me just write down what this is. Negative times negative is positive. I squared. Eventually I'm going to have to replace that with negative 1. Yeah, okay. And let's see where I'm at. So then negative I times 5 is negative 5i. And then I got negative 5 times negative I is plus 5i. And this negative 5x, Jeff. And then negative 5 times positive 5 is minus 25. Oof. Oh, I see what I did. I should turn it. Oh, it's not. So let's see. We got 5x's canceling. All right, we got the 5i's canceling. I squared, of course, is negative 1. If I would have done this, oh well, it's too bad. Negative 1 minus 25 is negative 26. All right. Gross. Now, let's see. Now, to be honest. Yeah, all right. That's fine. All right. So if you get a problem in the homework that says, create a quadratic function that has the solution 7i or something, what else must it have? If one answer is 7i, what other solution must it have? This might be a little weird, but... No? Let me write this in a different way. Say again? Yeah, negative 7i. So isn't 0 plus 7i, that's 7i. So what's this guy's conjugate? 0 minus 7i. So 7i's conjugate is negative 7i. I like it. And then you just put x minus 7i, x plus 7i, you multiply that stuff out. I like it, I like it. I know we're relatively new with complex numbers, but we have to start integrating them into our bigger picture. Since they are possible answers, we have to be able to work with them. Okay. Oh, because next thing I want to go to the blue book, I mean the green book. This is the green book, page 217. So first thing I want you to do is just take a minute and do that. Create this graph down here. Be really, really careful. Sometimes people forget. What do you get when you square negative 3? 9, not negative 9. Right? Just go ahead and take a minute, finish that XY table out, and then plot the points you get. Get a basic graph. We all should know what a parabola looks like, but this is just going to force you to create it yourself. And I'll probably do something different than what they do with this. See why this has the shape that it does. Obviously, to give away the shape, you should know the shape. So negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is repeating itself. Is this why the parabola has its basic shape. It's going to repeat answers. So 3, it's 9. I'm going kind of backwards. 2, it's 4. 1, it's 1. So it looks like it's headed towards, looks like it might be going down. But it's got to turn, of course, because we're using real numbers. I don't want to add that extra colorful level that, dude, let's pick it up now and get all of it. No. So when we graph in this course, it will be real number slice. Thank the gods, right? So there's no way this can go negative if I use real numbers. That's why it makes sense that it ends up turning. Right here it goes, oh shit, and it goes back up. Because there's no way it can go down here. So then negative square 4, negative square 9. I don't know why they made the scale all freaking like this, but you know. There. Okay. Hopefully yours looks less like it was stepped on by multiple people. Poor little problem. Now watch. I'm going to do something a little different than what they do on the next page, because I don't think what they do is quite as important. No, screw that. Now this is for x squared, right? What if my function was instead, let's say g of x, you guys all write this in, let's say g of x is x squared minus 4. And let's make another table of values for that and see how it changes. I'm not going to say much about this yet. I'm going to say a little more in a minute. So g of x is x squared minus 4. So let's use the same points they did. So negative 3. What do you get now? You've got to be really careful. People are being really loose about functions on the test. Plug negative 3 in. What do you get? 9 minus 4 is 5. And then this is nifty. When I plug a negative 2 in, negative 2 squared is 4 minus 4 is 0. Negative 1 in, negative 1 squared is 1 minus 4. Negative 3. And when I plug a 0 in, 0 squared minus 4. Negative 4. Now some of you guys might realize I'm going to start repeating again here now, all right? 1 squared minus 4 would be the same thing as negative 1 squared minus 4, right? You guys see that? Because when I square 1, I don't care if it's positive or negative, the answer is 1. So they're going to have the same answer. So this is going to be negative 3 again. 2 squared minus 4 is 0. 3 squared minus 4 is 5. So let's plot that on the same graph and then see what this thing did and why it makes sense. So negative 3 is 5. Where am I at? Negative 3. There you go, Jeff. Negative 5. Negative 2 is at 0. Negative 1 is at negative 3. 0 is at negative 4, and then it repeats itself, coming back up, coming back up. There you go. So here's the picture now. Make that big. This is g of x, and this is f of x. So if you just look visually, if you just wanted to, how do you tell somebody visually how the two graphs are different? I took this graph and how do I get the other graph? You take this graph and you
drop it down 4.
Drop it down 4. Yeah. If you take every single point and move it down 4, do you see how they all take this point, move it down 4? 1, 2, 3, Why does that make sense? Because look at the g of x. Isn't it whatever x squared is, this minus 4? So of course it makes sense that it moves the whole thing down 4. So if any of you guys are going to move into pre-calculus, possibly, a huge thing with pre-calculus is going to be this idea. It's called transformations. If I know the basic shape of something, I just move that shit around, make it skinny, make it fat, turn it upside down, based on what I see in the function. There's a lot less xy shit to do that. I don't want to do X, Y shit forever. I just want to go, looks like this, flip it over, make it fat, bam, I'm done. Right? Maybe. Now, so obviously, what would be true if I had a function that looked like this? It would take this basic function and do what with it? Move it up 3. I love it. So if I had a function that looked like this, it would take the square root that looks like this and just move it down 3, right? So whatever function it is, if I have function plus a number, function minus a number, it just moves it that much up and down. Are you guys with me? Maybe, maybe. Because remember what f of x stands for. What does f of x stand for? What did it take the place of? F of x took the place of? I'm with you. But what did it take the place of? I could say f of x equals 7x plus 9, but what we used to say? What letter? Y equals blah, blah, blah. So this is y. Y is, so up here it says y is what it was, plus 3 more. So every output becomes 3 bigger. Or 4 less, like we just did. That's why it makes sense that it's just going up and down. Like it. So, then a natural next question might be, I'm going to kind of skip through next page. Holy shit, what just happened? Oh no, what did I do? I should just try to start over. I don't even have a clue what button I actually hit. So on page 219, page 219. 219. Oh no, what have I done? Destroyed everything. That does not look promising. Oh, that's better. Sure. Three's off. No idea what I've done. This is really exciting. Crap that I have. Alright. Sorry. Unrotate that. Okay. No idea what I did to this poor dude. Come out back there? No. Maybe I should let it sleep for a little bit. Alright, let me let that think about things. Let's do some up on the board. We'll be fine. I miss my old chalkboard, to be honest. Alright. So what if I have, what's that first one saying again?
F of x equals x minus 3 squared.
Alright.
But it's in front of you.
I got it. Yeah, I know what, yeah. So this, I want you to, alright, I want you to really, this says whatever this was, take it down 3. Right? So whatever x squared, whatever that looks like, it's a u sitting at 0, now it's going to be sitting at negative 3. It's going to move the whole thing down 3. This is not the same thing. Where is the shift? Where's the shift? Why is it not x squared? Because now there's a negative 3 inside with the x. Now watch, this is kind of interesting. If I compare it to this guy, wants to make a lot of sense. If I make this 0, the output is 0. Right? Make x 0, I get 0. How do I get 0 up here now? What do I make x so I get 0? 3. You see how x has to get 3 bigger than it used to be? I want this to make total sense. What's the first thing I do to any input? Anything I put in here, what's the first thing I do to it? Take 3 away from it, right? So all my inputs have to be 3 bigger than they used to have to be to have the same stuff come out. So what would I put here to get 4 out? How would I make this 4? 2. I put a 2 in, and I get a 4 out. Yay! Or negative 2, right? What do I put in here? What do I put in this guy to get a 4 out now? Well, think about how do you get a 2 inside? You have to make it 5. Before I just had to make it 2. Now I have to make it 5. Because what's the first damn thing I do to my poor little input? I take 3 away from it. So I walk into the door of this bar, and the first thing I do is take a cover charge. Damn! I got less money than I did. I better bring more money next time so I can afford some, right? You guys kind of see what I'm saying? So if you go to this one bar, they take $10 cover charge. You go to this other bar, they take a $5 cover charge. So you have to have a little extra money if you want to go to this bar versus that bar. You have to have a little more to begin with. Never tried explaining it that way. I think I just want a drink. I don't know. So this, I really want you guys to see how it, if it's inside with the X, it's going to move left or right. If it's outside, it's going to move up and down. Why does that make sense? Because what does an X-axis do? Go left and right. So this is going to still look like a parabola. It's just going to be moved. So here, just to get you guys fully on board with me. And then I can check to see if this guy's feeling better after whatever I did to him. Finish this XY table and try to graph this. What you got, Jeff? Let's do... Do that XY table for this function and then try to graph it. All right. When in doubt, turn it off and turn it back on. So what we do almost all the time in math is when I'm not sure about something, I go further back and I analyze it a certain way. Then I try to make notice some patterns so I have less work to do for another problem that looks like this. So yeah, we look at this, we go, I don't know what this shit happens. Let's just do the old way. Plug stuff in. So what do you get when you plug a 0 in? 0 minus 3 is negative 3 squared. 9. There you go. When you plug a 1 in?
4.
1 minus 3 is negative 2 squared is 4. I love it. When you plug a 2 in?
1.
1. 2 minus 3 is negative 1 squared is 1. Is everybody with me? 3 gets
0.
4 starts to repeat.
1. 5
keeps on repeating. Where does it turn now? You can see by the numbers. Where does it turn? I think I know what you mean, but no, not at 0, at 3. Because look, isn't it decreasing? Then it's increasing. It turned around here at 3, 0. Yes, yes, yes. And where's the parabola normally turn? At 0, 0. So this sucker took the whole parabola, took that U, picked it up and moved it up 3. Why does it make sense? Because all of my inputs have to be 3 bigger than they used to. I have to bring 3 more bucks than I normally do if the first thing they do when I walk in the door is take 3 bucks away from me. Right? I walk in, 3 bucks. I brought exact change for this thing I want. Shit. Use a debit card, John. They don't take them. Right. So if I graph this thing, just to kind of finish this out. Let's see if I use... Stay with me. Where am I at? 1, 2, 3, 4, 5. Okay. 0 goes to 9. 1 goes to 4. 2 goes to 1. 3 goes to 0. 4 goes to 1. 5 goes to 4. So you can see now it's... I like it. And why does this make sense? How many times does this pass through the x-axis? How many times does it touch the x-axis? I think I heard it. My crappy-ass picture maybe, but it just touches it right there, right? Well, what's the answer to this? Equals 0. How do you make this equal 0? X has to be 3. So visually, it has one place where it equals 0, one place where it hits the ground. The ground is the x-axis. Maybe. So what would happen if I had this? Let's go back to here. Shit, I've got to turn my phone around. What would happen if I had this? What do you think? So let's go back up. This guy, what did this guy make happen? It made it move over 3, to the right, 3. That's what it did. All right, if I put that picture on here, it would be over here, wouldn't it? So what do you think this is going to do?
Move it to the left 4.
Left 4, I love it. So just to move it left 4. So I would have very little work to do. So let's graph this one the easy way. I already have x squared, I already have the base parabola here. Just take every point, move it back. 1, 2, 3, 4. I'm going to move it 1, 2, 3, 4. And I'm going to move it 1, 2. All right, Jeff, stop a little bit French. Move it back. 1, 2, 3, 4. Move you back. 1, 2, 3, 4. Look, they meet all. There it is now. How do I check my, that's kind of like my guess. This guess, based really poorly, to be honest. We only did one example, and we're like, we know. But, you know, I already know, so I'm sort of pushing in the right direction. How do you think I would check this? Yeah, what point is this? It's supposed to be negative 3, 1, if I would have just moved it up. Yeah, negative 3, 1. So if I plug a negative 3 in, I better get a 1 out. Do you? When you put a negative 3 in there, what do you get? 1. Sweet. Whenever you graph something, you can check what you just did by taking a point and making sure it works. Don't worry about this 2 yet. That's the thing I skipped for now. So let me push this a little bit. So whatever number's in here moves it left or right. Whatever number's out here moves it up or down. Whatever number's in with the x moves it left and right. Why does that make sense? Because the x-axis goes left and right. Whatever number's out here moves it up or down. But here's the thing. Let me see. Now that I got all that out there, let me see if you guys really get this, because this is what makes everything kind of come together better. Now I got it all out there. Let me write it like this. So this one, let me just do this one basically for you right now. This would move it, two things are happening. Do you guys see that? So it's going to move it right 2, up 5. So then the first thing I have students ask, and I love this question because it's a smart freaking question. Why the shit is there a minus and it goes forward, but there's a plus and it goes up instead of down? Math boy, tell me that. This is why. I love this. If I move that, can I move that 5 over here with the y? Of course I can. Just subtract it over, right? So now I've got the numbers with their letters. And this explains a couple things. So how's the y going to change? How are the output's going to change? They're going to go up 5. And how are the input's going to change? They're going to go up 2. You know, to the right 2. You've got to be careful with up and down. You have to be 2 bigger, and the y's have to be 5 bigger. Do I normally write it like this, though? No, I normally have this on the other side. Its sign changes, so then I don't have to think backwards about that piece. I have to think backwards about this piece. So so watch. So here's the beautiful part of this. What is the most important point on the basic parabola picture? Not the x-intercept in general. In this case, it is the x-intercept, but and in this case, it does go through 0, but it doesn't always have to, right? The most important point, does anyone know what that point is called in
The
general?
vertex?
Vertex. I love it. You can even call it the turning point. That's what it's called sometimes. That is basically the most important point. So if the economy is like dying, but we see it sort of doing this, we're like, please, dear God, be a parabola, not one of these weird shit. Right? Please make that turn for real. Are you guys semi with me? Okay, okay. So right now, this is at 0, 0. If I move the parabola, what was the last, I can't remember. What was the one I just gave us? X minus, what was the one with two things?
The x minus 2 plus 5.
Yeah, so x minus 2 squared plus 5. So I would move everything over 2, right? To the right 2, and then up 5. So where's the vertex going to be? 2, 5. Because it starts at 0, 0. So how do I find the vertex of a parabola that's in this form? I just look at the numbers and I know what they are. It's sort of like saying I look at the y equals 3x plus 2 and I know what the slope is and I know what the y-intercept is just by looking at this shit, right? So if I have something, where'd you go? Oh yeah, you're over here. In this form, I know that the vertex has to be at 2, 5. And it is basically the most important point. So what if I had something, let's keep going on the same idea. What if I had something that looked like this? Where would this guy's vertex be?
7, 11.
Careful.
11,
No.
7.
I love you guys.
49, 11.
No. What makes it 0?
Negative 7.
So when it's with the letter, you do the opposite. If the first thing I do is add 7. So if I said, come over to my house, bring $10, but you know your friend's got 7, how much money you have to bring? 3. You can bring 7 less. So x plus 7, the first thing I do is add 7 to the input. Every input must be 7 less than it used to be. I know that's the most frustrating thing about this, is one of them you change the sign, the other one you don't. But that was the whole purpose for me. If I subtracted the 11 over, put it with the letter, I change both frickin' signs. It's just that I don't normally write it like that. So this basically make this 0, and then this piece says whatever the hell that is, add 11 to it. So it's going to go straight up 11. Yeah, lock it. Now, the last little thing, let me go back and talk about this guy. I like to do this last because it's sort of like an extra little bit. What does it do when I put a number out here, like this 2 in front? Well, basically, look at it the same way as before. There's my x squared. There's what it looks like. Now, in this one, I'm saying every y is going to be twice what it used to be, right? So here's the x squared. This is what they graphed for me. Now every output is twice what it used to be. So what's this output right here? 1. So now the output's going to be 2. And sure enough, if we put a 1 in there, of course they get 2. This output was 1, now it's 2. This output here was 4, now it's going to be 8 off the picture, right? 8 over here also. So what happens when the number out front is bigger than 1? It gets really skinny. Because what's it saying? It's saying that y is twice x squared. So if y equals x squared is the dark line that was there. Y equals twice that. Every output is going to be twice as big. Well, what happens to this dude, of course? Twice 0 is... It's just sitting there going, all right, whatever you guys want to do. Maybe. So what's going to happen if I put a 1/2 in there? It's going to cut all my outputs in half. I'm going to get fatter. So it's kind of backwards again, right? If it's twice, it becomes skinnier. It's sort of like a slope idea. It should go up faster, twice as fast. 1/2, it should go up half as fast. It's not quite exactly equal to that, but it's roughly the idea. If you get to calculus, you really learn how to do slopes of anything, not just straight lines. Or not. It's okay. All right. And then the last little thing, let me change this last guy. What happens with this guy? Now what's going to happen to every output? Every output used to be this. Now it's going to... So here, what's the output at 1 originally? The dark black line, that's what was there at the beginning. What's the output? 1. Now it's going to have an output of
Negative.
-1. Everything's going to become the opposite. This is what we call a reflection, because math people are very creative.
It looks like it's color reflection.
So if it went through 4, now it goes through -4 here. -4 here. So just like the parabola is reflected underneath it. Oh shit, well, I almost got it. It's sitting on top of a pond. It's got a little reflection in there. Aw. So that negative is what we call a reflection. It reflects it, in this case, around the x-axis. All the outputs are the opposite of what they used to be. So you have this, we're not going to get that deep into this stuff. But in pre-calculus, you are going to get pretty deep into this stuff if you get to pre-calculus. But I love, you look at the function in a different way. You say, okay, here's what it was. What does this do to it? It makes all the outputs negative of what they used to be. So that's why it flips the whole thing over. So what if I had negative square root of x? It would take this and just flip it over. Now it would look like that. It would become its reflection. Okay. The most important thing is, they went a little too far with this. I want to tell you about the reflection. So it's going to be a parabola that opens down is the important part here. And if it's positive, it opens up. That's the difference.